Hey, hi, how are you all? Hope you are doing really good. So, now we'll talk about this important topic tautomerism or tautomers. You may have seen many questions coming from this topic in your exams. First of all, what is this tautomerism? So, this is a special type of isomerism. Now, you all know that isomers are those who have a same molecular formula and same vapor density. Why so? Because vapor density equals to molecular weight by 2. So, those who are having same molecular formula, same molecular weight, that means they are also having similar vapor density. Okay. So, many students sometimes get confused that isomers only have same molecular formula. No, they also have same vapor density. Now, tautomers are a special class of isomers. Now, first of all, sorry, their structural isomerism. Okay. Now, second point is they are also known as desmotropism. This tautomerism is also known as desmotropism or ketotropism, prototropism or allotropism. And what happens actually in tautomerism, the two tautomers are in equilibrium. So they are in dynamic equilibrium. That's why they are also called dynamic isomers. Now, in a nutshell, if I just describe tautomerism in a simple line, then it is actually nothing but intramolecular proton transfer. Intramolecular means what is happening inside the compound. Okay. So, intramolecular proton transfer. Now, the very last point is at a very low temperature and in absence of catalyst, these two tautomers can be separated. Now, you might be thinking that what is the point of learning all these points? But if you carefully examine the pattern of the exams recent days, then you may see the questions are coming like in a statement pattern. So you should know at least some important point of every topic. Now, what about the requirements? All compounds don't show tautomerism. So the requirements is simple. Two requirement only. The first one is it must have a sp3 hybridized alpha carbon. I'll show you later. And the second one is that sp3 hybridized alpha carbon should have at least one alpha hydrogen. Only then the compound will show tautomerism. Okay. So now we'll see how many different kind of tautomerism can be seen. Okay. Okay, so the first one, it is known as 1,3 system. So why it is named so, we'll see, and what is happening here we'll also see. Suppose I am taking acetone, CH3CO, CH3. Now here see, what is this alpha carbon? Alpha means just beside this carbonyl group, that means it's having two alpha carbon. This is alpha carbon, this is alpha carbon, right? And you see the first option is first requirement is done. It is having alpha carbon. Now you have to find whether it is having alpha hydrogen or not. Now see, this is having 3 hydrogen and it is also having 3 hydrogen. That means 6 alpha hydrogens, right? So it is also having alpha hydrogen so that it will show tautomerism. Now I'll let you see the pathway of tautomerism. Suppose I am showing this hydrogen like this. Now you name it like 1, 2 and 3. Okay. Now what will happen? Now what will happen actually? So this hydrogen will be abstracted and then this bond falls on this bond here and it will form a double bond here. So it will end up with this form. So this is having a keto group, that's why it is known as keto, and this is having one in means double bond and all means alcohol, so it is known as enol. So it is known as keto enol tautomerism. And why this is 1,3 system? Because you see the transfer is happening between 1 and 3, right? This oxygen is abstracting and then this is at this 3 position the hydrogen is there. So 1,3 system. Now many students think like in 1,3 system there is only this ketonal tautomerism. It is not so. It is also having another example. We'll see some of these examples. Okay. Suppose the next one is you're having it is a nitro group NO2. Now what will happen? This is 1, this is 2, this is 3. So the hydrogen, this is sp3 hybridized alpha carbon, and it is also having hydrogen. So this hydrogen will get transferred here and the double bond will come here, isn't it? If we show you like this, what will happen? It will be like this. So CH2 double bond N, oxygen and OH. This is known as acid group. So this is known as nitroacetautomerism. Okay. And it is having lots of examples actually. Suppose I'm writing this hydrogen like this for your better understanding. This is oxygen. So this is a nitroso group. Now again the same thing, 1, 2, 3. Little transfer will happen and the double bond will come here. So we'll end up with CH2 double bond NOH. This is known as oxime. So nitroso oxime tautomerism. Okay, this is another type of tautomerism. And another could be, suppose amide CH3CONH2. Okay, the same thing it will also happen here. The hydrogen transfer, then proton abstraction. So it will be OH here and double bond NH here. I am showing again. So this is amide and this is known as imidol. Okay, imidol. Amide, imidol, tautomerism. Okay, so these are some examples of 1,3 system. Now we'll see 1,5 system. Okay. So in 1,5 system, I'm giving an example. CH3, CH double bond CH, CHO. This is known as crotonaldehyde. Okay. Now you see 1, 2, 3, 4, 5. So here the hydrogen, the carbon is sp3 at 5th position and it is also having hydrogen. Okay, so this is known as 1,5 system. It's not only 1,3 tautomerism is there, 1,5 tautomerism is also there, and in the recent days the questions are coming from this 1,5 system. Okay, so now what will happen? I'm writing this hydrogen like this. The same thing will happen. This oxygen will abstract this hydrogen and then this double bond and this shifting of double bond. So we'll end up with the product like CH2 double bond CH, CH double bond COH H. Okay. Another could be this is phenol, and I am adding this nitroso group here, NO. Okay. Now what will happen? What will happen? This oxygen will abstract this hydrogen and then shifting of this double bond. Okay. So what will be the product? It will be double bond NOH. Okay, so this is known as nitrosophenol nitrosophenol, ketoxime, tautomerism. Okay. Okay. Now the next one, it's a very common example. So this is diene and this is a one ketone. So this is known as dienone. Now what happens here? Now if you even number 1, 2, 3, 4, 5. Okay, so it's having hydrogen, 2 hydrogen. I am showing only 1 hydrogen. So this will abstract this hydrogen and the double bond shifting. See, phenol. So this is known as dienone phenol tautomerism. So I hope you understood how many different types of isomerism are there. And if question comes like this, the first question, that this is formaldehyde, this is acetaldehyde, and this is CH2CH3. Whether these three compounds show tautomerism or not, you first search whether it is having alpha carbon or not. You see here, there is no alpha carbon, so no point of further checking the second requirement. Here you see it is having alpha carbon and then it is also having alpha hydrogen, 3 alpha hydrogen, then it will show. Here it is having alpha carbon and 5 alpha hydrogen, it will show tautomerism. Okay, so these are some things you should take care. And another kind of question also comes in exam. Suppose this compound, they will give you these compounds to confuse you, no? This is methyl, this is also methyl. Whether this compound show tautomerism or not. Now you see, this is having alpha carbon, it is having alpha carbon, alpha hydrogen, so it will show tautomerism. Another thing here, they might ask you question whether this will show 1, 3 or 1, 5. Now we see 1, 2, 3. So 1, 3 it will show. Now you see 1, 2, 3, 4, 5. It is also having hydrogen. Like the same example I have shown here. So it will also show 1, 5. Okay, so you have to take care of this also. Now suppose this example. Suppose this example now. Here methyl, here methyl. Now you see, it will only show 1, 2, 3. It will only show 1, 3. No 1, 5. So I hope you understood the concept. Take care. Bye-bye.